A very good morning to you all. I hope all of you are doing fine and learning R. So today we start with file handling in R, right? And basically what we're going to study here is how to open a file, read a file, and write something into a file in R. And we've partly done this when we're talking about dplyr or when we're talking about ggplot2, but I wanted to make a dedicated lecture on file handling in R. So some of the lectures that are a prerequisite for this lecture would include number one, setting up of RStudio, installing RStudio, then how do you set up RStudio, lecture number 4. And then, of course, it would be good if you have some idea of dplyr. Dplyr, anyways, is a very common library that is used for data wrangling and data manipulation, and this is something that we'll be using very frequently. So I would suggest that you can go through these 3 lectures if you have not already gone through them, and then come back to file handling in R. Right? And before moving on, I must thank all the subscribers and people who have not subscribed but are coming to the channel. The channel is really growing. We have had more than 11.5K views as of today, and you can see there are 854 subscribers as of now. And on an average, I get 100 views per day, which is a good starting point. I mean, I would want to increase it to as much as possible, but this is a really nice starting point and a break-even point for the channel, right? So then with that, we start our lecture on file handling in R. So we are in RStudio again, and we start with our actual script. And I'm sure you remember this is a scripting area. And in my case, I get the console on the right-hand side on the top panel by going to settings here. And then, of course, at the bottom panel here is the environment panel. And this would list all the variables that you use in a program. And this is our viewer area. It also has other tabs like files, plots, packages, help, etc. So it is usually a good practice to define your default path. That is basically the path of the folder from where you can read or write a file directly. So I use the command set wd or set working directory, and in round brackets within inverted commas, I define my file path. In my case, it is going to be the fdisk, and the folder name is R human genome. So I can also show you physically where this folder is. So this is where we are now. So any file that is present in this folder can be directly read without defining the path. So let me now run this part first. So I select this and say run, and you see my working directory has been set to fr human genome. And to confirm that my working directory has been set to R human genome, I would just use the command get working directory or get wd without any arguments. Let me run this as well. So when you run this, it tells you now that your default path is the fdisk and R human genome folder, right? So any file within this can be directly read without giving the file path. Next, we come to step 2. Step 2 would be loading the libraries that is to be used. And if you're going to use the library for the first time, then you also have to install the library first. So the command to install a library is install.packages. And let's say we're going to use dplyr here. So we say dplyr, right? Installation is a one-time affair. Once the package is installed, you don't have to install it again for calling it the next time. To call the library in R, you can directly say library and in round brackets, the library name. So here we are running this. The library dplyr has been loaded onto your script. So we now come to the first method of opening a file in R, and what we're going to use is the command read.csv, because the file that we're going to open is a comma separated values file. So here we are, we use data1 is the object into which we're going to read the file, and we say data1 is equal to read.csv, and again, round brackets and double inverted commas, we give the name of the file. We do not define the file path because we're already in the same folder. We have already set up working directory to this folder here. This is followed by a comma, and then we define header equals to true, which means that the first row in the file is actually the header, right? And if you see, I've commented the bottom line. This is basically to show that had we not defined our working directory to the current folder, then to access the file, I would have given the full file path, right? So let me execute this part here. So this is the only line that is to be executed. You say run, and your file has been read, and whatever data was there in human genome.csv has been transferred to the object data1. If you can see here, data1 contains 25 observations of 8 variables, which means there are 25 rows of 8 columns. So we are going to use the view command. Remember, the V is capital here. And in the round brackets, we give the argument data1 because we want to see what has been read into the data1 object here. So when you run this now, a separate tab is going to open where your file would be shown. So here you are, this is the data1, and you can see this is the same file as we used in dplyr earlier. So that is why I'm again suggesting that if you've not gone through the dplyr video, you can go back to dplyr and then come back here, right? So this is the file of the human genome. All the chromosomes are listed here, 1, 2, 3, 4, 5, 6 until 22, which are autosomes, and then we come to X and Y, the sex chromosomes, and then the extranuclear DNA, which is the mitochondrial DNA, is also specified here. The second column consists of the size of the chromosome in terms of base pairs. The third column is the number of protein coding genes in each chromosome. The fourth column is the number of pseudogenes reported. The fifth column is total long non-coding RNAs for each of the chromosomes. And then, of course, total small non-coding RNAs, microRNA, and rRNA. So what we're going to do next is to use dplyr to select only chromosome, name, and base pairs column and print it out to a new file. So till now, what all we have done is to first set our working directory, second, load the libraries required, and third, read the file using read.csv command, right? And now we have the data with us. So now we are going to create a new file and write this data into this file. So we are going to use dplyr to select specific columns and write them onto a new file. So if you remember, first what we do is we transfer the contents of data1 to hg1. And then we also use a pipe here to indicate that this data has to be processed further. And what is the process we're going to do? We're going to select specifically 2 columns. So we use dplyr verb select, and then we define the columns that we want to keep. So these are chromosome and the base pairs, right? And this has to be exactly the same heading as is present in the header of that column. And then, of course, we say hg1. So that is to see what comes in hg1. Run. And you can see the hg1 shows up here. It has clearly one chromosome column and one base.pairs column. And this one here is the number of rows. And if you don't want this row number to be written onto the file, you have to give a specific row.names equals to false. So now we go about writing the file in R. So to write a file in R, you need 2 basic arguments. First one is what is the object that you want to write, and second is the file name that you want to give to your file, and also the extension that you want to give to your file. So we first write our data into a CSV file. So we say write.csv, and in round brackets, we define the object that is to be written. In this case, it is hg1, which is having 2 columns here, the chromosome name and the base pairs in the chromosome, right? And then to define the file name, we say file is equal to hg11.csv, right? So this is going to be the file name, hg11, and the extension is csv because we're using the write.csv command to write the file in comma separate values format. So to ensure that the row numbers also do not come up, so you say row.names is equal to false. Let me run this part, and if you've noticed, for running the part, most commonly what I do is select and then go to run and click on run to run it. But there is also a shortcut here. You could just click on the end of the line and say control enter. Control enter. And you see the command has been executed here. Where is your hg11.csv going to be formed? It is going to be formed in the same folder that is your working directory folder, right? So that is going to be F drive and R human genome folder. So let me just show you here. The file name here is hg11.csv. So if you see here, this is your R human genome, and you should have an hg11.csv file here. So this is your hg11. So here you are. This is your first column, chromosome, and this is your second column, the base pairs, right? So next we write a text file. So we say write.table. And again, we define our object, which is going to be hg1. And then we give the file name by saying file is equal to, and in double inverted commas, the actual file name hg11, and also define the extension that is going to be .txt here. And then again, we also define that row.names equals to false. So let me run this part again. So now you know you don't really need to select. You can directly put the cursor at the end of the line and say Control Enter. So here you are, your command has been executed. So let's see hg11.txt. So we go back to the same folder here, fr human genome, and here we're looking at text document hg11. So if you see here, this is our file again. So coming on to method 2, and in this case, we're going to use the library data.table. So first we load the library onto the script. So here you are, you say run, and your library is loaded here. So we equate data3 to fread, and in round brackets, we give the file name that we want to read. We don't have to define the file path because we're already in the same directory as where the file is. So you say run and your file is read, right? So if you see data3 is equal to fread humangenome.csv. So what we'll now do is we'll transfer the contents of object data3 into hg3, which will be further processed as is indicated by the pipe here, right? So what is the process we're going to do here? We're going to add a new column to this data that is going to be genes per megabases. And to add this column, we are using the dplyr verb mutate, right? So we say mutate, and then we say in round brackets genes per MB. This is going to be a new column that is to be calculated, and this is being calculated as the number of protein coding genes divided by the length of the chromosome, and that further divided by 10 to the power 6 to get the number of genes per megabases of a given chromosome, right? And you say run, and the file is run. And we run. So when you run it, a parallel tab will open where you'll be able to see hg3. So if you see here, hg3 now contains all the columns and observations that are found in the original data, plus it also has a new column that is genes per megabases. And this is basically the number of genes divided by the length of the chromosome in megabases, right? So let's now go and write the result to a file. So now let's execute this part and also look in our directory where hgalt.txt is. So let me just do Control Enter, and the command is run, right? So now we go back and check for hg_alt.txt. So again, we are in fr human genome, hg_alt.txt is here. So we can click here. So here you are. So this contains your additional column, genes per megabases, and the values for each of the chromosome in terms of genes per megabases, right? So now we come to method 3 of opening a file in R, and this is basically what is known as the file.choose method. So when you use the file.choose method, a menu will open up, and that will allow you to select exactly which file you want to select. So we say data4 is equal to fread, and then in round brackets, we say file.choose. And again, we open and close a round bracket. So this is basically a file.choose function that will allow you to select a file from a file menu, right? And then, of course, with a comma, we say header equals to true and separator equals to comma. So we're going to open a CSV file here. So if you see here, we've used the file.choose command. This will open up a file menu, and from there you can move to any directory and browse and open the file that you want to open. So let's execute this here. So you say run, and you have a file menu opening up here, and now you have to select a CSV file, right? So we will take this one here as a CSV file. So we say open, and there you are, your file has been read. If you say data4, it will show you the data that is present in. You say run, and here you are. This is your file, chromosome and base.pairs, right? So let's now talk of method 4 of reading a file, and this here is particularly reading an Excel file, right? So the library that is used is library read Excel. So we first load the library read Excel here. So you say run. So the function used to read an Excel file here is read_Excel. And then, of course, in round brackets, you define your file name, and this is equated to HG. So HG is the object where the file is finally going to be read. And then you can say view HG to see what is there in HG. So here we are going to read this file, and let me run the command. I say run, and the file is executed. And then we say view HD with a capital V and run again, and the command gets executed. So here is your file again. This is your HT file. Okay. So remember also we are in RStudio, and RStudio is an integrated development environment. So many things that you can do command line, you can also do via the click of your mouse. So for example, here I can say import data set, and I can specifically define which type of file I'm going to open. So let's say we're going to open an Excel file. So from Excel, and then it has given you the options of the URL where you can go and select, or you could directly browse your local system. So you go up here and you go to again F, our human genome, it is opening by default, and we're going to load the Excel file. So here we are, we load this, and so here is a data preview. You can see the top line is the header, and you have the header names, and then followed by the actual observations there, right? There are 8 columns and 25 rows of observations. And then, of course, the object name into which the file is going to be read is going to be human genome. If you want to change it, you can change it here. The sheet is default. This is the first sheet. And then if you see here, it is written first row as names, which indicates that the first row is the header, right? And the pseudocode is generated here, if you see. So this is library read Excel, then human underscore genome equals to read Excel, human underscore genome dot Excel SX, and then view human genome is given here. So let's now say import so that the file gets imported onto our system. So here you are, this is the file now, the human genome file, the original file here, right? And then again, you can do processes on your file and write to a new file. I've already shown you how you can write to a new file, so we'll not go into that again. So in today's lecture, I've shown you 4 command line ways of reading a file into R. And then also I've discussed the import dataset functionality and how you can import a file onto your R working environment. So we'll stop here. And then, of course, I hope this is useful. Please do spread the word and subscribe to the channel, and also share it with your friend circle. Thank you very much.